Hello everyone and welcome back to the 8th tutorial of this video series in which we are learning how to use Python to manipulate files. And specifically in this tutorial we're going to be looking at the different ways of manipulating Excel documents. So to get started with this, you should have OpenPyXL installed on your operating system. So to do that, you're going to have to open a command window, and then we're going to use the pip install method, that is the Python installer packages, to install OpenPyXL. And so in my case I've already installed that, so it's only going to say that the requirements are already satisfied. So the most common Excel file extensions that you might encounter when dealing with Excel documents are the following three: .xlsx, which is default XML format Excel files, the .csv, comma separated values, which is a bit different than the XLSX file format, which does not support multiple worksheets. So there are certain functionalities which are not available to us. We cannot create or multiple worksheets in those type of documents. And we also have .xlc, which are Excel charts. But for the most part, we're just going to be dealing with XLSX documents. So to get started with creating an Excel document using Python, we're just going to import OpenPyXL, okay? And then creating a workbook, which is basically the same as creating a document. Okay, so from OpenPyXL, we're going to import workbook. We're going to set that to a new class, and then I'm going to use the workbook.active method to instantiate a new worksheet. And then I'm going to set the certain cell values A1, B1, A2, B2, and A3, B3 of that worksheet equals to these string values inside of the document. And then I'm going to specify the file path which I want to save the document as. And before any changes will occur, you will need to have to save the workbook by passing in the file path to the file name attribute inside of the save method. And so upon running that, we can then go inspect our file directory. We see that we have created this new document, which is called this underscore document is automatically generated using OpenPyXL for testing purposes and may be deleted. Okay, so upon opening that, I see this new document with worksheet called sheet 1 having string values in the cells A1, data 1, data 2, data 3, and in the column B I have value 1, value 2, value 3. Okay, so I'm just going to close that, and I might keep my directory open because I'm going to refer to this a lot and we're going to have to open this document often. It is not necessary for me to reinstantiate the workbook class for me to be able to set any of the data inside of that workbook. It already exists. All I have to do is to use the load underscore workbook method and pass in the file name for where this workbook is located on my machine in my directory for me to be able to access any of its information and to write any new information to it. So here I've assigned it to the variable XL underscore workbook, and I can now find out more information regarding that workbook. For example, if I want to find the sheet names, I can just type XL workbook dot sheet names, and then it will print a list of all the available sheets in that workbook. So if I open that, I'm going to see a new sheet here called sheet. That's the original name that we've instantiated over here. Okay, and then I can actually go and manipulate further aspects of that sheet itself as follows. By using the XL underscore workbook variable that we've already created over here, and then in the square parentheses, that since this is a list, I will pass in the sheet name, which I've gotten by referring to the sheet names list, this last list that was printed, and passing in the specific index for that sheet name, which is in this case the only sheet name available in that list, which is at index 0. Okay, and so that will then be assigned to the variable XL underscore worksheet 0. So now I have a variable for my worksheet that I can then go and manipulate specifically for that worksheet alone. If you prefer to keep things simple, you can just refer to the same worksheet by using the name that you see appear inside of the worksheets list and passing that into our XL underscore workbook variable as follows. And so upon printing XL underscore worksheet 0, it's going to give us this object, which is a worksheet object. And so you can then refer to your worksheet in the same way as before. It's just less confusing for most beginners to be able to identify this as that worksheet that is seen in that list. Very simple thing that we might want to be able to do in Excel is to be able to rename our worksheets. So for example, if I open this Excel workbook, I want to change the name of sheet to something else. So to be able to do that, well, here's a short piece of code, which is really elementary. It's just a bunch of methods that I'm referencing. And so first line is, as we already know, is to open or to load this workbook, and then obviously referring to the sheet name by name, and then assigning that to the variable XL worksheet 0, and then specifying the method .title and changing that to whatever name that you prefer. In this case, I'm going to change it to worksheet, and then saving the document. Okay, so up and running that and inspecting my document, the name down here has changed to worksheet. In the case that I don't know what the worksheet's name is, it's better to use previously discussed method to refer to the sheet names by index within the sheet names list. Okay, so in this case, I will always be referencing to the first sheet in the workbook. Okay, and so that knows every time that I only change the title to a new title, it will know which sheet that I'm talking about. Okay, instead of having to specify inside of these square braces over here the name sheet. Okay, for example, so in this case I'll just refer to that by index, and I don't need to go and check what the sheet name is to pass it in as a string variable over there before it can actually be updated. So this will work just fine as well, and we'll actually see that the name, which is now worksheet, will be changed to worksheet 0. Okay, so up inspecting that, you'll see it says worksheet 0 over there. Okay, great. So we can also go and create new worksheets. So in our case, we only have one that exists over here, worksheet 0. But I can go and create a new worksheet called new_worksheet_00. And all I have to do is to refer to my XL_workbook object, which is the workbook that was instantiated at the very beginning when we created this document. And then pass into the .create_sheet method. We have to pass in a new worksheet name, and you can go and change that upon your will later on using the previous method I've showed you. Okay, and then all you have to do is to save that document. So that's quite easy. So when I run that and check my document, I should see a new worksheet 00. Okay, the problem with that though is that if I run it again, it will not even keep the same name, but it will still create a new worksheet. And if I go inspect that again, I have another worksheet named 001 because it just took the first two characters from my worksheet and it appended a 1 to it because that one already exists. And so if I do it again, I will get 002. And that's quite frustrating, okay, because you might not want to create a worksheet if it already exists. And so to prevent that, we can just write a test before it implements that method. Okay, and so here's how I would do that. I would just write a check if statement. In other words, I would say that if new_worksheet_00 not in XL_workbook.sheetnames, in other words, our worksheet names list, then you can create the sheet called that new_worksheet_00. Otherwise, print that it already exists. So I'm going to run this and it should say that it already exists. Okay, so I can go and check that, and yes, it does exist. There it is. That's why I did not create it. Okay. But I can also delete worksheets. And to delete worksheets is actually just as easy as creating them because we're just using the built-in methods. So here's an example where I have already created the first worksheet, new_worksheet_00, new_worksheet_001, and then 002. And I want to just delete those to start fresh with a different type of illustration and keep my document ready for further discussion and so on. So I'm going to run this and inspect this document to see that, hey, those worksheets have just been removed. Okay, so the method that we're using here is we're referring to the Excel workbook. That is the document that we've created here in the first place when we started this tutorial. And then I just append to that the .remove method, and I pass in the Excel workbook object with its name for reference to that worksheet. Okay, so once again, I could have specified it a bit differently, but I think you get the gist of it. So, and some of the operations that you will always need when working with an OpenPyXL manipulating the Excel documents is, for example, to find the maximum number of rows. So on this piece of code I have here a variable num_rows, that's the number of rows in my worksheet, which I've assigned to the XL_worksheet 0 variable, and then I've called the method max_row to find the number of rows in that worksheet. And so if I print that and then call the num_rows variable, it's going to give me 3. That's because I have 1, 2, 3 rows in my workbook. Okay, I can also call the number of columns, doing something very similar to that by changing the max rows to max column, and the same with the number of rows, change that number of columns, and then calling that variable num_columns will return 2, since if I open this worksheet over here, we can see that we have 2 columns. Okay, so that's always useful because we sometimes need that to find out where can we place new values without affecting the already existing data and not overwriting that data. We would want to place that beyond the number of rows that we have in the next column or in the next row, or maybe we only want to change data up to the last row or up to the last column. So then we really need to rely on this method. So I think this is a really fundamental operation to have in Excel. So once again, I can call the max underscore columns method and it should still return 2. Alright, so that's just a little simpler than referring to the worksheet names inside of a indexed list over here. But the advantage of using the indices is that no matter what the name is inside of this list, I can perform certain operations and tasks on my worksheets based off of indices. So for example, if I'm going to use a for loop or something like that, I can pass in a variable I here which iterates over all of the worksheets. So I don't need to necessarily type out the names in a string format. I can just iterate over the indices. So that's the advantage, but for this audience that prefer simpler method, that's how you would refer to a worksheet as well. So there are two more operations that I think are very fundamental to using Excel in general, and I think the first one that we need to look at is the delete rows method. So obviously that is for deleting a row. So if I open my document here and say I want to delete the third row over here, how can I do that using this OpenPyXL library? So to do that, I'm just going to refer to the worksheet as we've instantiated it as a variable before over here. We said XL underscore worksheet 0 is XL underscore worksheet and referred to that sheet name by name, and then I'm going to call the delete underscore rows method, and then I'm going to pass in the index for the row that it should go and delete. Okay, so that's only going to delete the specific row at index 3. Okay, and then I obviously have to save that workbook before any changes may occur. So let's just test that. If I don't save anything and I run that, my workbook will look the exact same way as before. Nothing has been deleted. But as soon as I instantiate that .save method and I run that, now my worksheet has deleted that last row. But what if I would like to delete a multiple number of rows? Well, then unfortunately you're going to have to remove the index equals. You're just going to pass in the index value and you're going to pass in the number of rows that it should delete from there onwards. So if I want to delete from the first index and I want to delete 2 rows, then I'm going to pass in 1,2. Okay, so it's the first index and then the number of rows from that index, and that basically means I'm going to delete everything because there is only 2 rows left in that document. And so when we go look in this document, there should be nothing in there. Okay, cool. That's pretty cool, right? Well, let me just delete this document and build it from scratch so that we do have some data to actually manipulate a little bit and play around with. Because what I would like to show you next is how we can delete columns instead of rows, and so obviously that's very much similar to what we're doing over here. So I'm going to change the delete underscore rows method to delete underscore cols and then pass in the index. Since we don't have 3 columns, we only have 2 columns, and I'm going to delete the second column. I'm going to pass in index equals 2, and upon running that and inspecting the document, we should only have 1 column, the first column remaining. But I can also delete multiple columns by referring to the delete underscore cols method and then using the index to start with. That's the first number, that's the first argument, which tells me which index should I start with and up to which columns I then should, how many columns I should delete starting at that index. So in this case, because we only have 1 left, I'm only going to delete the first column starting at the first index, and therefore it's only going to delete the first column. And if I run that and inspect my document, I should have no columns remaining in my document. Okay, cool. So once again, I'm going to rebuild this document by deleting it here first, and then I should obviously also just reassign the variable by loading the workbook so that I don't run into any problems here later on. So these are the basic operations. So there are at least 2 more operations that are quite fundamental when dealing with Excel documents. And the first of these is that we need to at least be able to insert a certain number of rows starting at a certain index. So for that, I have this short piece of code, which is quite self-explanatory, but I'm just going to run through it. So what we're doing is that we're loading the workbook, which we've already created up here. And then we are assigning a variable name to our worksheet inside of this, okay, by referring to the sheet name inside of the workbook list. And then what we're doing is on that variable, we're calling the method insert underscore row. And then we also giving it two arguments. The first argument is the position or the index at which we would like to start inserting rows, and then the number of rows that we would like to insert as the second argument, which is 3 in this case. So you will see that upon using the .save method and passing in the file name, if I run this piece of code and open my workbook over here, you're going to see that on the second line we have inserted 3 new rows. So we get this as a result, 1, 2, 3. Okay, and so something very similar to this is the insert underscore columns method. And so to do that, it's pretty much the same thing, except this time you should use the correct syntax, which is to specify cols, not column. Okay, and upon running that, inspecting our document, we should see that I've inserted 3 columns from the second line onwards. Okay, cool. So we can do quite a lot of things at this point. If we go and combine all these techniques, we can do some quite interesting things in Excel. And so over here, I've written a short algorithm which will delete all the empty rows. And we can do something very similar for deleting all the extra columns. Okay, and so what's happening is the first 2 lines are self-explanatory. That's just loading the workbook and referencing that specific worksheet in our Excel document, this worksheet over here, which we've already changed the name of. But because we're referring to it by index, that's okay. We know that it's the first worksheet. Okay, and then over here I have an empty list of indices, which will later be sorted and collect specific index values based off of this criteria over here. And the criteria is in a for loop, because what it will do is it'll go through each row up to the last row that has anything in it, and it will change this flag value to true if this condition is satisfied. In other words, if the cell dot value is not none, in other words, if the cell is not empty, it'll change that to true. If the cell value is false, on the other hand, it will append an index value I, which is specified in the for loop, and then it will sort the index list, and then for each row with the index in the index list, it will go ahead and delete those rows. And it will only stop at the last row. Index equals index plus 1 minus I. Okay, and so then the document will be saved. So if I run this and go check my document, we should no longer have any of those empty rows over there. And so for the columns, to delete empty columns, if in case you have any empty columns, let me actually add empty columns before testing that and changing it and testing it. So all we have to do here is to change rows to insert underscore columns. If I run that and open my document, I should see that I have 3 extra columns that are unwanted. And now I can go and copy this algorithm and change the dot rows to cols. And now I have an algorithm to delete columns. You don't have to keep this and rewrite it every time. You can actually build a function of it, okay, but I'll show you how to do that a bit later. For now, it's just okay to have this in the back of your mind for further reference and application later on. So in this short section, we're going to look at how we can actually access the cell values and write to the cell values within a worksheet. And so to do that, we've already seen the first method by passing in the column and the row within inverted commas inside of the square brackets as an argument to the sheet name, and then setting that equals to some value. Okay, so that's one way of doing it. The other ways of doing it would be, obviously, you would reference your worksheet, and then you would call the .value property to get the actual content of that cell. So in our case, since this is set to value at B2, so if I open this document, you would see that is the correct value. Then that's one way of doing it. And the advantage here is that I can actually I can set this equal to a new value. So for example, if I want to test a new string in there and go and inspect that, okay, in this case it wouldn't have done anything because we still need to save that before any changes appear. So to do that, let me just save the Excel workbook by referencing the method .save and passing in the argument for the file path. And upon running that, you can then see that this is actually changed to test. Okay, so that's one alternative way of doing it. But there is another alternative way of doing that. But as I said, there is an alternative way of doing that using the cell method. Okay, so in the last case over here, I have Excel underscore worksheet 0, that is the sheet name. And then I call on the cell method Okay, and then on that, well, for argument to the cell method, I pass the row number and the column number. And in our case, we don't have 6 rows. I'm just going to reference 2. That will be the second row and the first column. So we're looking at A1 over here. And then I call the dot value property on that to display to the screen basically the same content as A2 over here. Okay, so I can also then still use that same method to update the value. And say, for example, I want to put test2 over there. But I still have to save my workbook by including this line, file path. And so upon running that and opening this document, I should see that it says test2 inside of that cell. Okay, but I can also reference a range of cells, and that's what we're going to be doing next. So if I want to reference a range of cells, I can basically pass in as argument within the brackets, the square brackets for the worksheet name. I can just reference that as starting at A1 and going all the way, highlighting up to B5, as if I'm doing this manually by opening this up and going like that, A1 to B5. That would be this grid over here. Okay, so that's pretty much the same thing. So if I run that, it'll just store that to the variable value underscore range, okay, in a list format. And then I want to run through each of those values. You can do that in different ways. It depends on what you're actually trying to do with this data. So one way of doing it is to write a for each loop that iterates over the value range variable and then extracting each of those cell values. So I'm actually specifying here to print a dot value and also b dot value, where a and b are the two cells adjacent to one another in this value underscore range. Okay, and so running that gives me basically all the code. The problem is that I've highlighted more cells than what I actually have data for. So it's going to return none in our case over here because there are no values in those cells down below over here. So from A4 to B5, there are no values, and so it returns none. Okay, so let's just do another example of that. And in this case, I'm going to reference the cells A1 to C5. The difference here is that I now get 3 adjacent cells, and so it wouldn't work if my for loop only contains AB. I should also include A, B, and C, and then print all those values. But that's frustrating because I'm always going to get this none over here because I'm referencing cells that don't have anything in them. And for that, you might want to use the min-max row method and the min-max column method that we've discussed previously to limit yourself in terms of fetching data, or you don't want to go and make a selection over here in your worksheet for cells that don't contain anything. So I'm going to illustrate to you how to do that in a bit. But for now, I want to get you familiar with the basics so that next time when we do discuss more details, we can actually, perform all those tasks much more easily. Okay. We can also iterate over the rows by using the .iter_rows method and then specifying the minimum number of rows that we would like to start at, then the maximum number of rows that we would like to go up to, and the same for the columns, the minimum number of columns and the maximum number of columns. And then I'm going to print those rows to the screen, but unfortunately this is just an object. So to get those rows, I'm going to write a for loop that iterates over those rows. Okay, so for each row in rows, print the row, and it's just going to give us a list of rows over here. So these are not yet the values. If I want then to extract those values, I'm going to have to print the values as I did before using a for each loop with A and B. And since I know I only have 2 columns, it will only need 2 parameters here, A and B. Okay, and so running that, it should give me data 1, data value 2, test 2, test, etc., etc. So I can also reference columns alone. For example, I'm now referencing all the cells within the column A. Okay, and now I can extract the values using a similar method for a in value underscore range print a dot value as in the previous case. And it just gives us the first column's values. So it doesn't have to be a selection or a grid of cells or something like that, because they can still do the same thing with a selection of columns. In other words, if I open this document and I want to select A, B, and C like that up there, that's pretty much the same thing as what I'm doing inside of this line of code over here. I'm referencing this Excel sheet, Excel underscore worksheet 0, and I'm passing in the column to start with and the column to end with, and I'm printing the value range in a cell format. So as I said, we can extract those values in very different ways, and depending on what you would like to do with your data, here's an illustration of how to append your cell values to lists so that you can then use this in Python in various different ways. Okay, so what's happening over here is that I'm iterating over the rows, starting at the first row, ending at the 7th row, starting at the first column, ending at the second column. And then I have these two empty lists which will capture the data over which I iterate. All right, for the first column, I will append the value from that cell, okay, starting at the first row, going to the second up to the 7th. And I will do the same for column 2. So I'm actually doing this in terms of columns. And then I'm going to print those values on the screen. So it's going to give me two lists. So that's column A, data 1, test 2, data 3, none, 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 because there are no values set to those cells. And then the same thing for column B. Okay, that's quite easy. And so I just want to point out that when you try to overwrite any cell values, you have to be a little bit careful because it's very easy to make the mistake. Okay, for example, within that cell A2, so that's row 2, and column 1, that's A2, I can just leave this as an empty string. Okay, and yes, when you do open your Excel document, you will see that nothing is within there. But if I go and find its value, if I want to check what's inside of it, right, by referencing the dot value property to find the cell value, it'll just not give me anything back. However, it should have returned the value none, because an empty cell not having any data in it is classified as the variable value none. So to correctly set that value in Excel, you have to set it equals to none. Okay, and upon running that, it'll then obviously save the file and then also print the value there for me. Okay, so if I open that, it still shows nothing, but the correct data type is now set to none. And that's how you should do it. We can also set the Excel cell value to numeric values. So for example, in this case, I'm going to set A2, that means the first column in the second row. I want to give it the value of 23 so that we can actually do calculations with those numbers. In fact, I'm just going to copy the first piece of code from the very beginning of our tutorial. And instead of passing in string values, I'm going to set each value in our two columns, A1, A2, A3, B1, B2, B3 equals to these values. Okay, because I'm going to use that to illustrate how we can then use formula within Excel using Python. So here I have set the values in the sheet for the cells A6 and B6. I've actually set them equals to this string, and inside the string I have two very common formulas from Excel which always start with this equals mark. So I have to also include the equals mark within the inverted commas because that's actually going to have to be placed together with the rest of that string inside of that cell. And then I'm going to sum everything from the first row to the third column. And then for the second column, in the B column, I'm going to also pass in a different formula, a very common formula equals average. And then I'm going to reference to cells B1 all the way up to B3. Okay, and so I'm going to save that. And then when I open this document, I should then see a new number appear, which was not manually typed into this cell over here. We've generated those values based off of our Python code over here. Okay, so that's quite easy. So the problem with this previous method over here is that the cell values A6 and B6 are referenced in a static way, and it's kind of awkward to explain because what I'm saying is that you have to know beforehand that the value A6 falls below the last row in your data sheet that actually contains data that you don't want to overwrite. Okay, so that's what's the problem over here. You don't necessarily want to place your formula at A6, and you don't want to actually have to open the document to go and check to do that. So the way to do it is to do it dynamically, and that's what the max_row method that we've previously spoken about, that max_row property is quite useful for. And so I'm now setting that equals to this row variable. So the reason I'm doing that is because I wanted to automatically kind of go and detect at which row we have last inserted data before we decide to place a new formula below that. And in this specific case, three rows below the last row. Okay, so what's happening here is I'm using the Python formatting method, okay, which will then read anything in the inverted commas, which is also contained inside of curly braces, as variables and normal Python code, and then it will render that as a string so that we can then go put that in our Excel sheet. Okay, and so the same thing over here, I'm formatting this string and first checking that anything between the curly braces is a variable, and so it shouldn't be understood that that value is equals to this value over here, which is actually equals to 3. So in fact what we're doing is we're sending that formula equals sum, and we're arranging over the cells from A1 all the way to A3. Okay, so this is going to place it in the cell A6. This is going to place it in the cell B6. It's going to sum all the way from A1 to A3, and this is going to average all the way from B1 to B3. Okay, and so these lines of code are actually exactly identical to the ones above, except that, as I've just explained, these are dynamically detecting the last maximum number of rows and then making sure that we don't overwrite any of those values, but instead move 3 lines down and then put our formula in that cell instead. Okay, so upon running that and then checking this document, I get my average and I get my sum. Okay, cool. So in this section, we're just going to look at how to style or format our Excel document using OpenPyXL. And to do that, we're just going to import from styles the font library. And our first example here, we'll just set them manually. We're going to set the cell variable equals to the cell A1 in our worksheet. And then we're going to refer to the font method and pass in the attribute size equals to 12. And then set the value of that cell equals to hello. For the second cell, A2, we're going to do the same thing, but we're going to change different attributes. We're going to give it name of Arial for the font. All right. And we're also going to set the size equals to 14, as well as the color to this hexadecimal value, 00FF0000. And then for the cell at A3, we're going to set the name to Tahoma, and we're going to set the size attribute to 16, as well as the color attributes to that hexadecimal value over there. Okay, and so if I run that and inspect my document, you can see some changes have occurred. It's red and green. It's no longer so plain and boring. But I can also change the alignment. For example, if I import the alignment library over here and reference to my workbook that's already over here, we're just going to load the workbook. All right, and then I'm going to reference to cell A3, and we change the content of that cell to OpenPyXL. And I'm also going to refer to the alignment method and then set the text rotation attribute equals to 90, so that it's going to be vertically downward. The string content in that cell will be vertically aligned to be at 90 degrees. And so upon saving the changes and opening this document, I can see that I now have this cell which is formatted so that the text appears vertically aligned. But we can also color the cells as we normally do in Excel to give it a bit of life. And so for that, we would need to import the pattern fill library. And then I'm going to just set my color yellow equals to this hexadecimal string, so that I don't have to type the hexadecimal value each time. I can just refer to it as yellow. Okay, and then so what this loop does is that it'll set the attribute for color. Each second row equals to yellow. What the symbol is just the modulo symbol. I'm not going to go into all the maths about it. I just want you to understand that that basically just skips each second row and goes to each second row, and then it sets the color by referring to the pattern fill method and then passing the attributes start underscore color equals to yellow and end underscore color equals to yellow, and then the fill type equals to solid. It will render to this beautiful document over here. Okay, so each second row, first, the third, fifth, the seventh, and the ninth rows are all set equals to yellow. Okay. We can also set borders for our cells using the border side library. Okay, and so I'm just importing my document and all that other stuff, and then I'm referring to the border method, and within that I have also to set the attributes left equals to side, and then the style equals to thin, right equals to side, and style equals to thin. So that's just telling border method which sides would I like to include a thicker line or a thinner line, and how would I like my borders to be set. Okay, and upon saving that, I've then assigned to the border property this new variable that I've just cleared over here, thin underscore border. And so upon rendering that, I should get one of my cells, B2, which is completely highlighted with a black border around it. Okay, cool. So there's many ways of doing borders. That should probably suffice, but here's another example, border 1 and border 0. And so say that you would like to frequently set your borders in this manner, then you can go and define a border for yourself. And then what you could do is that depending on for which row you would like to set that border, you can go and do that. All right, so that's really not that complicated. If you open that document, you should see now I have all the way from B1 up to B20. I have a border on the right, and that's it. That's pretty cool, right? So in the next section, we're going to be looking at how to draw graphs, charts, and images in Excel using OpenPyXL. And so to be able to do that, we have to import the bar chart and the reference libraries. And then I'm going to just reference to my worksheet. Over here, I just have some data, which I call rows. So in the first row, I have the headings. In the second row, I have numeric value 1 up to 7. Those are our indices. Then I have some string values and I have some numeric values. Okay, and so basically what's happening is that I'm then appending values to my worksheet by iterating over the row. And then I'm instantiating a new chart by calling the bar chart method over here. And then I'm setting my values using the reference method. Okay. And then I'm appending to my chart, which is that class over there, bar chart. I'm referencing to the add_data property, the add_data method. And I'm passing in the arguments of values, which is this list over here that we've created, and also the titles from data to set equals to true. And I've also set titles underscore from data attribute equals to true. And then I provide it with a chart and I tell it where I want the chart to be placed. Okay, and so then I save the document. Upon running that, it created a new workbook for us. And then opening this new document bar graph, which is what our document is now called, we see that we've created this selection of data, this grid with serial number, roll number, and marks. And it's used that then to create this bar chart over here. Okay, so you no longer have to go and draw bar charts in a very manual way. Excel can do all that for you using Python and OpenPyXL. So here's another example of a graph. I'm going to use the line chart class and the reference class. Okay, and so we instantiate a new workbook. This workbook will be saved as line graph. We provide it with some data, which is the names for the months. And the first heading is empty because that will just contain indices 1, 2, and 3. So I have January up to December. And then we're going to iterate over the rows, which is this selection of data over here. And then we're going to say that for each of the values inside of the rows, we want to append to our spreadsheet so that we can create our spreadsheet. And then we're going to create a random range using the Python random library to generate values from 5 up to 100. Then we're going to construct the line chart by calling the line chart class. And then we're going to take this data using the reference. Okay, we're going to use the add_data method and append that to a chart. We're going to give it the data that we've defined over here, and then we're going to tell it that from rows attribute should be set equals to true, and the same with the titles from _data attribute should also be equals to true. Then we're going to instantiate that by calling the .add_chart method, providing it with the chart and telling it at which position we want our chart to appear. Then we're going to save this graph and it's going to build a new document, which upon opening the document gives us this beautiful graph over here. Okay, so it's not specifically meaningful data. The data, once again, as I explained over here, is a random generated values. So it depends on your use case. If you had data that was obtained through, for example, an SQL database or anywhere else, perhaps your boss sent you some data to analyze, or perhaps you're trying to extract some data for a real life experiment or simulation that you've done, then you can go and do this in very much a similar way by building yourself a Excel document using the OpenPyXL library and then following along with some of these familiar steps that you see over here. So for our last example, I just want to illustrate to you how we can use images in Excel. We have to reference the image library from openpyxl.drawing.image. Okay, and so I'm going to build a new workbook because I don't want to overwrite the already existing ones that we have over here. And then I'm going to declare a new variable over here called logo, which is going to be instantiation of the image class. And then I'm going to provide it with the raw string, which is the file path to where my image is located. And if you look at my directory, you would see that I have a resources folder under which I have a file called image.jpg. So basically this image class is going to grab that file. And I'm going to set the logo height and the logo width to 150. And then I'm just going to say append to the sheet the add_image method and then pass in the logo variable, okay, as well as the position at which I want it to appear. And I'm going to save the file as image.xlsx. Upon rendering that, I get a new workbook. And upon opening that, I see that I have this new image, Python OpenPyXL. So if I zoom in, congratulations, you've made it to the end of this tutorial. And there is much more to discuss, I guess, but to keep this concise and short and to the point, I would like to conclude at this time. And then I will see you in the next one.